Okay, so this is some kind of clamp mechanism. You can see it's subjected to a force here, F. We want to find the vertical clamping force over here. Now, let's just kind of examine it. You can see this base plate is bolted down to the base. I'm not going to worry too much about that. The handle itself, we have a force applied here. It comes up. There's a little link connected here, CD. What is that?
Two-force.
That's a two-force member. So that's going to be one unknown at C. We know the direction. And then it swings up to this point B, and B looks like a pin. And so there'll be two unknowns there. So I have if I look at a free body diagram of B, C, and the end of the handle, this kind of curved piece, I'm going to have two unknowns at B and one here at C. I should be able to find those values in terms of F and, of course, whatever A is. Then that information will transfer to this kind of T-shaped unit. I would know BX and BY. What don't I know? AX and AY. And then over here, this contact force is a single force perpendicular to the distance. So there would be 1, 2, 3 unknowns there. So I can break it apart into two free bodies with 6 total unknowns. So let's start with the curved handle. I'll just kind of draw it as a curve. And I have my force F applied out here at the end. And over here, I have the force in CD. Let me go ahead and pencil in that that's a 60 degree. And then I swing up to point B, and at B I would have two unknowns. So I'll assume BX and BY. I should have drawn this in blue, right? Can't really go over it very much, but I'll try to go over it. So those are my three unknowns. So we'll call this free body diagram BC. And then once I get that solution, I'll apply it to a free body diagram of ABE, and we should be able to find it. So how do I find all this? Let's see if I can put in some distances here. So it looks like from this point of contact over to A, what is that distance? It looks like it's that's going to be hard to. What is that force? Do I need to know that? Maybe I don't need to know that. Well, I know the distance from here to here is what? A over 2, right? And the force here, well, the distance from B to that force would be 2A. I think that might be all I need. All right, so how can I find, I'm trying to get this value for F to work all the way through to E. So how do I get this force F as quickly as possible into BX and BY? Basically, how do I find BX and BY? What do you guys think? What if I sum moments about B? What will I get? I'll get CD in terms of F, and then if I have CD, I can sum forces X and Y and get BX and BY. You see that as a good strategy? I think if I try to sum moments at C, you'll see I have both my components. That'll give me one equation and two unknowns. If I sum moments anywhere else, I'm going to get all three unknowns. So it looks like the best place to start would be at B, where I can eliminate two of my unknowns and find CD. Even though I don't need it right now, that's not going to help me. It seems like it's not going to help me. It really will. So let's sum moments about B. So to help you visualize this, I'll go ahead and try to pencil in here my two components. Probably won't look very well, but you'll see there's an X and a Y component. Let's start with the vertical component. What's the vertical component of CD? It would be F CD sine 60. And what's its moment arm to be? It would be
A over 2.
A over 2. And that would create positive moment about B. What about the X component? Well, that's going to be CD cosine 60. And it's going to have a moment arm of, again, A over 2. Is it going to create positive or negative moment about B?
Negative.
Negative. And then finally I have F. And F creates what kind of moment about B? Positive or negative?
Negative.
Negative. So I got negative F, and its moment arm is this distance, which looks like 2A. So I should be able to solve for FCD in terms of F and A. Let's see. I can factor the A over 2 out. Well, first of all, I can divide everything by A, right? Since this equation is equal to 0, I'll just divide everything through by A. So A goes away, A goes away, A goes away. So I should have cosine is 60 divided by 2 minus, sine 60 divided by 2 minus cosine 60 divided by 2. Add those together and divide all that into there. Oh, I can also, I guess I can multiply everything by 2. That would take care of this. And this would just become 4. I tried to simplify it a little bit for you. So let's see what we get. I got 10.93 F. Did you guys get that? Let me try it again.
Yeah.
Is that what you got?
Yes.
10.93? Anybody else get that? Go for 3, see if you can get a trifecta. I did it twice and got the same answer. You guys get it? All right, so now what I can do is I'll sum forces in the y direction. So I have By acting up. I have the y component of CD acting up, and the y component is FCD sine 60. And then I have the force F acting down. So if you put that in there, you should be able to find By. I got a negative 8.46. You guys get that? Anybody get that?
Negative 8.46.
Yeah.
Yeah.
And that would be 46F.
Yes. Yeah.
That kind of makes sense. If you push down here, you would expect the balancing force about this point would By would have to be down also. That's reasonable. And then we'll finish this by summing forces in the X direction. This one should not be as complicated. I have Bx to the right, positive, and then I have the negative component of FC, CD, which will be the cosine of 60. So it looks like Bx is just going to be 10.93 cosine times 5.47. Anybody else get that?
She got 5.46.
No. Close enough. So let's kind of separate that. And now let's look at this blob, this kind of T. I'm going to just draw it as a line. So what I have, and this is the connector. So what I'm going to have at the bottom of that is the actual contact force pushing up. I'll just call it N. And then this is what I assume for Bx and By on free body BC. So over here it has to be what? Equal? And opposite. And then I'll come to point A and I'll just assume AY and AX. And see, this total height here is A, and this distance looks like 1.5 A. Now remember, I'm just trying to get in this contact force. So I've already found By and Bx. So where's a great place to sum moments?
About A.
About A. So if I come here and sum moments about A, first of all, AX and AY, I don't really need those values, and they won't create any moment about A. BY will create no moment about A. Only BX will. And BX will create positive moment with the moment arm of A. And it'll be reacted by the normal force, which creates negative moment, with the moment arm of 1.5A. So it looks like the normal force is just going to be Bx divided by 1.5. And we got Bx as 5.46, so I divide that by 1.5. I get 3.64. Oh, wrote 6.64 F. So whatever, if I push down, say 100 pounds here, the resultant force through this mechanism is 364 pounds. That's pretty good. It's like almost 4 to 1. So any questions about that? You just have to work your way through it and break it down, identifying as many two-force members as you can. And remember that once you solve for pin forces on one body, you can just apply them to the connecting body. They're not different. They don't change. Any other questions?